Here, we want to determine the following collisions if they are elastic or inelastic. Okay. Block A, mass 2 kg, slide into block B, mass 2 kg. Before collision, block A moves to the right with 5 meters per second. Block B is at rest, stationary. After collision, block A is stationary, and block B moves to the right with speed of 5 meters per second. So,
looks pretty elastic.
initially, we have block A, B. So V2 equals to 0, and V1 equals to 5 meters per second. M1 equals to 2 kilograms. M2 equals to 2 kilograms. Okay. After collision, block A will stay there. Okay? So U1 will be 0, and block B will move with U2 equal to 5 meters per second. We want to determine if it's elastic or inelastic collision. Okay. So how can we determine it? We know that we have to calculate the initial kinetic energy and final kinetic energy. There are only two ways you can tell if it's elastic or inelastic. One way is by comparing the initial kinetic energy and the final kinetic energy. Another way is by asking me. Okay. So let's look at what is the initial kinetic energy. Initial kinetic energy, K initial, should contain two terms, kinetic from A and kinetic energy from B. So it's 1/2 M1 V1 squared plus 1/2 M2 V2 squared. So this is 1/2 multiplied by 2 multiplied by 5 squared plus 0, right? Velocity is 0, so kinetic energy is 0. So it's 25. Now let's calculate the final kinetic energy. Again, it contains two terms, 1/2 M1 U1 squared plus 1/2 M2 U2 squared. In this case, U1 equals to 0. It stays there after collision. So kinetic energy for is 0. And this is 1/2 multiplied by 2 multiplied by 5 squared. So this is 25 J. So is it elastic or inelastic?
Elastic.
Elastic, since K initial equals to K final. It is elastic. Okay?
Did you use conservation of momentum to solve that or no?
I didn't use the conservation of momentum because I already tell you all the velocities. So you don't have to solve for any velocity. Well, I already tell you all the velocities. V1, V2, U1, U2. Okay? But you can check the momentum. The momentum is of course conserved, right? The initial momentum, what's the initial momentum? 5 multiplied by 2 plus 0, 10. What is the final momentum? 0 plus 5 multiplied by 2, again 10. Okay? So momentum is also conserved. And that's my work. When I give you these numbers, I already solved the equation to get the final velocity.
Wait, say that again? You gave us what number?
I'm just commenting that how to get these final velocities. I already solved the momentum conservation to get this velocity. But that's not in this problem. Okay, now let's look at another situation. Block A of mass 2 kg slides into block B of mass 2 kg. Before collision, A moves to the right with speed of 5, B is stationary. After collision, A is moved to the right with speed of 3, and B moves to the right with speed of 2. Okay? So what happens is that for this problem, before collision, in this case A and B still has 2 kg, M2 equals to 2 kg. This is still at rest. What is the initial velocity for this one? 5 meters per second. Okay. After collision, now you get a different final stage. Both of them move to the right. What is U1? 3. What is U2? Okay.
Is that M2 equals to 2G?
2 kilograms.
I mean, what's the subscript in the end? What's the subscript in the end? Is that 2 or 1?
M1 equals to 2 kilograms, M2 equals to 2 kilograms. Okay. In fact, I think I should make this 2 and this is 3. Otherwise, it will be quite weird. Yeah. Okay? That wouldn't change our story here. So, again, we want to tell if it's elastic or inelastic collision. If I didn't give you the answer, then you have to check initial kinetic energy and final kinetic energy. The initial kinetic energy is still this one. So with the same calculation is 25 joule, right? And final kinetic energy now is 1/2 m1 u1 squared plus 1/2 m2 u2 squared. So it's 1/2 multiplied by 2 multiplied by 2 squared plus 1/2 multiplied by 2 multiplied by 3 squared. So this is 4 plus 9 is 13 joule. So is it elastic or inelastic? Since K initial is larger than K final, okay, it is inelastic. Any question here? So you just need to compare the initial kinetic energy and the final kinetic energy. And if you want to compare the initial momentum and final momentum, which one is larger? Initial or final? Or the same? The same. Momentum is always conserved. You can check that initial momentum is 5 multiplied by 2, 10, right? Final momentum is 2 multiplied by 2, 4, plus 3 multiplied by 2, 6, 4 plus 6, 10. The same as the initial momentum. For any collision process, momentum is conserved. There is no change in the momentum. Now, finally, if after the collision, 2 blocks stick together after collision, so is it elastic or inelastic?
Inelastic. Completely inelastic.
Inelastic.
But it says right there, if K1 equals K up, it's elastic. I don't understand.
2 blocks stick together in motion, how do you know K initial equals to K final? Right? 2 blocks stick together has nothing to do with K. So here I'm not even looking at K. So how do you know it's elastic?
Inelastic.
Because by the definition, if two blocks stick together, it's called completely inelastic region. It
Right.
belongs to inelastic region, right? It's just a special case of the elastic region, or inelastic region. Okay? So I would like to add this. After you do all this calculation, you need to go back to check these simple facts.